Adams State College. Great stories begin here.
Okay, it's my pleasure to introduce Amy Scavezze. We started this research project last summer. It's a collaborative project between us and the University of Northern Colorado. So we spent some time in the field. Amy was with us last summer out in the field, and then she went out in the field on her own to finish up the field work. And then she's been working in the lab and putting this project together for her senior capstone project in GI. So let's welcome Amy Scavezze.
So I'm Amy Scavezze, and my project is on using soil analysis to reconstruct the glacial chronology of Snow Lake Cirque in the Never Summer Mountains of Colorado. It's just a brief introduction. There's been a lot of glaciations up in Snow Lake Cirque and lots of cirques. And so what we're trying to do is find the relative ages of landforms that are glacial to find out which one's older, which one's younger, maybe one was deposited during a older glaciation, and kind of create a chronology finding relative ages. And we're using a pedochronology, which is just the idea that as soil develops on two separate landforms that are made up of similar material, the soil development will be indicative of the relative ages of those two landforms. So the research question then became, what are the relative ages of the glacial landforms in Snow Lake Cirque? So we'll start off by learning some glacial landforms. A cirque is a depression in the side of the mountain with steep walls that's been carved out and formed by perennial snow or glacier ice. And it has an open side in the down valley direction. So I'm standing on the open side here, and down valley would be behind me, and this is actually Snow Lake Cirque. And then a moraine is the other glacial landform I'll be talking about. And a moraine is just glacial deposition. So basically, as a glacier recedes, or as it melts away, it kind of scoots backwards up the hill. And in places where it might stop for a while, there's like flow happening within the glacier and materials being deposited out. So in places where it stopped a while, it would create kind of a berm or a hill that's called a moraine. And there's two types of moraines in this picture. Oh, meant the laser. Right here is called a lateral moraine, so that's along the side of the moraine. And then right up here is called an end or recessional moraine, so that would be the moraine stopped right behind that for a while and deposited that and then back, or the glacier deposited that and then backed off. And this is, sorry, this up here is the cirque that I just showed you a picture of. And so here we have an aerial image and a map. You can see Snow Lake Cirque is in north central Colorado, and here is Snow Lake Cirque up here. Those two pictures, I was standing right here for that first one, and then down valley here a little bit more. There's three landforms I'm really looking at in Snow Lake Cirque. First right here is the North Moraine, and then right in here is an unknown landform, and then over on this side is North Moraine, South Moraine, unknown landform. So for this next image, I'll be standing right about here on this end moraine looking down valley. So here's a panoramic image of me standing on that end moraine. Here's that North Moraine, here's that unknown landform, and then over here is the South Moraine. And you can kind of look and imagine a glacier up in this valley. You could see that this could be the side of it. Maybe there's an end moraine right here, and it kind of wraps around, and that would be the other side of it. So that's what I was imagining as I chose this landform to sample. Dr. Beaton and I had come up in July and sampled off of this moraine right here, the North Moraine, and so I was trying to complete that kind of encompassment of the glacier there by deciding what I thought the other lateral moraine was. And so I chose this landform right here, and I'm calling it the South Moraine. And then there's this mystery landform that we were kind of dumbfounded by when we saw, and we're kind of guessing at what that is. So here's a picture of the North Moraine again. Here I am standing on the North Moraine looking across at the South Moraine up over here. And then I'm standing on the North Moraine, and this is the unknown landform, and that's a hiker. So just to kind of give you some scale there. It's a pretty big chunk of something. It's also located down here. They call this the Michigan Lakes, one down here and then one up over here. And you can see around it here used to be underwater, it looks like. So I think that's kind of interesting. There's water around most of it. So my hypothesis is that the that the North Moraine and the South Moraine were deposited at approximately the same time, and so the soil development would be similar on that, making it similar ages, and that the unknown landform is the youngest of the three. I think it was deposited after the glacier receded again. So the methods I used were soil analyses. I did research on local glaciations, and then I studied glacial geomorphology research, so how glacial landforms change over time. And that's one of the reasons that soils was chosen to do this, is the soil development on them. So what I did was I took a catena of each landform, and each position here, a summit, backslope, and toe slope, they're all known as geomorphic positions. And so a catena is a sequence of geomorphic positions. So on the North and South Moraine, I took a sample on all three of these positions, and on the unknown landform, if you remember, there's a lot of water around it. I didn't take the toe slope there, so I have the summit and back slope of that one. So here's a quiz. Which geomorphic position am I in here? Anyone? No, no. Here we are, geomorphic positions. I'm standing on the backslope, okay. So this is actually me digging the catena samples, or the samples on the North Moraine. And we have the summit hole here, backslope hole here, and the toe slope hole will be down here. So that's actually on the North Moraine. So in studying soil, we need to understand kind of how it develops. Soil develops in layers known as horizons, and on top you have organic material, actual living plant matter, and then the A horizon is commonly known as topsoil. It has the most organic material of all the soil horizons. Below that we have the B horizon, which tends to be more clayey and usually have a different type of structure. And then we're going down as far as the C horizon, because we're calling that the parent material. The R down here refers more to like bedrock. We're not looking for bedrock. We're looking at glacial deposits and then soil building up on those. So the deposits would be cobbles or chunks of rock, and then the soil is developing on top of that. So we're looking for C horizon, or also known as the parent material. And then as soil develops, it begins to become structured, or develops a structure to it. And it starts off as a granular structure. I know you can't really read the words, but you can see the pictures. This is granular. And then you get into these two down here are blocky. We have subangular blocky and then angular blocky. So that's what we're looking for in our soil development. So the analyses that I ran on the soils were organic carbon content, the amount of organic particles in the soil, and then the structure of soil, clay content, and the thickness of the B horizon. All of these can be indicative of the age of the soil, although some of them kind of carry different weights. Organic carbon content can show an older soil. It can also show a soil that's exposed to a different sun angle or different types of precipitation, so it's useful, but it's not really solid on its own. But the rest of these, structure will develop stronger and more defined structure with age, and then clay content will become higher with age, because soil forms by eroding down the parent material, and that erosion is a continual process, and the particles will continue to get finer and finer. So the more clay content, the more erosions happened, the longer the soil's been developing. And then the thickness of the B horizon is a good indicator, because A horizons will tend to hit like kind of a general thickness within an area and then level off, but B horizons will continue to get thicker with time. So we're looking at these things to tell us the age. These are charts that I made. They show us the depth of the holes I dug, and then the clay and organic carbon content. So on these charts we can see the thickness of horizons, as well as the clay content and organic matter content of each horizon. And if you'll remember, we had our catena, so we had summit, backslope, toe slope. So this is the North Moraine on the summit, this graph, and the South Moraine on the summit here. So we're going to compare some things here. You can see the A horizons are pretty similar in thickness, and the green line here is clay content, and the blue line is organic matter content. So let's look at clay content real quick. Both of them start at just over 10% of clay, and then at the B horizon, this one goes up in clay content, up into the 20s, maybe 25 almost percent, and this one drops in clay content. And here there's a BW, signifying a weakly developed B horizon. And then it goes down into a C horizon, which would be the parent material. The thickness of this B horizon is only maybe 5 to 10 centimeters thick, whereas you have the first B horizon over here, which is like maybe more like 10 to 15 centimeters thick. This one goes straight from one B horizon into the parent material, and this one goes from one B horizon into another. And if you notice, we dug a much deeper hole on the north moraine than I did on the south moraine, because there was so much clay in the soil it was taking me forever to dig. And I would have spent all day digging this hole. So then we have the unknown landform at the summit position also. And this one's kind of interesting. It starts at 15%. Let's take a glimpse back real quick. Both of these started at just over 10%. The north moraine dropped after that, and the south moraine went up to almost 30%. This one here starts at 15% in the A horizon and peaks out around 25%, and then drops back down to a little less than 15%. So it has kind of this weird like peak in clay content, but it also has, but yeah, then we can also look at the organic matter. Less than 10 goes down to a little less than 5. And up here we have organic matter. The north moraine characteristically has more organic matter in it throughout all of this research than any of the others, but both of these have more organic matter than the unknown landform. So here we are on the back slope position. So gone from the top of the hill to the side of the hill. You can look again, significantly more clay in the south moraine than in the north moraine. The north moraine is starting just below 10 and it peaks out around 20. What's interesting here is the thickness of the A horizon, or sorry, the thickness of the first B horizon here, maybe 10-ish centimeters thick, and the thickness of this B horizon is from about 30 to 90 centimeters, so 60 centimeters thick, significantly thick. On the other hand, I don't know how far down this horizon goes. The lettering you see after that, the B is the B horizon, the T signifies high clay content, and the K signifies that there's calcium carbonate in there also. So I don't know how thick this goes because again there's so much clay I couldn't dig fast enough to get out of there before nightfall. So it'd be interesting to go farther down. But here we'll look at the back slope of the unknown landform. We start at about 5% and go to maybe 7% for clay content, whereas with both of these there's definitely more clay on both of these. And if you look at the organic matter here, we have from about 10% down to maybe 4, and then here about 6 or 7% down to maybe 3 or 4. So kind of similar in the organic matter content there. Clay content's really what I find most significant here, as well as the thickness of the horizons. And then we're on the toe slope now for the north and south moraines. Here you can see the difference again, significantly more clay content on the south moraine and more organic matter on the north moraine, as well as an extremely thin, maybe 3 or 4 centimeters thick, weakly developed BWJ, meaning B horizon weakly developed juvenile soil, and then straight into the parent material. And over here we have the A horizon with 3 B horizons after it, so significantly more soil development underneath that A. But then we start to get into the structure, and it goes granular, subangular, angular is kind of the structure we're looking at as far as from least developed to most developed. And there's some interesting structure patterns here. On the north moraine, which according to clay content was looking a bit younger, we have more structure in the A horizon than on the A horizon of the south moraine. And also in the first B horizon there. And then we get into the parent material here, and then a second B horizon here. So it's kind of interesting. The unknown landform has granular structure throughout the entire profile on both of the digs. So then you can also look at the structure here. We have the same structure for the A horizons for north and south moraine, same structure for B horizons, and then here we hit BC, meaning mostly parent material with some soil development and some structure in there, but it's granular structure. And then here we have a BTK with angular blocky, so very well developed structure. And again, all granular structure throughout the entire profile of the unknown landform. And here we are on the toe slope. Again, subangular blocky structure in that A horizon and granular structure in the A horizon for the south moraine. So some more structure on that north moraine. And then the B horizons look similar, and here we hit the bottom of the profile with the parent material and no structure because there's no soil development there. And then here we have the continual B horizons that go down until we don't know how far. So some interesting things. The conclusions I've drawn is that the south moraine appears to be older than the north moraine based on mostly the thickness of the B horizons and the clay content. The structure kind of throws it for a loop there, but I also think that since Dr. Beaton and I went out together in July and sampled the North Moraine, and the structure gets characterized in the field, so we were looking at that together and characterizing it together. And then in September I went by myself and I was characterizing that South Moraine by myself. There could be some ambiguity between the fact that two people were working on that. Also, clay content is measured in the lab with a very precise experiment that's done, and structure is just something you look at in the field and you decide on the spot. So it kind of holds a little more weight there. Although the structure does not negate the clay content conclusions, it just kind of throws in a little spin there. And then the unknown landform appears to be the youngest of the three. And then my discussion questions to kind of follow up on this research, I think it would be best to go back out and resample, especially on that South Moraine, and find the end of the profile, hit the parent material, and see really how deep down that profile is. That would help a lot to figure out some of these things. I also think that the peak of the clay content on the summit for the unknown landform, when it peaked up to like 25%, I think that's really interesting. I'm not sure why that is, so I'm kind of curious to go sample several more spots on top of the summit there and see if there's continual clay content across the top of that unknown landform, see if we can find a pattern. And then I'm curious to know what the parent material of the unknown landform is for, because when I was digging the holes and when I hit the parent material, it seemed to be sort of different shaped cobbles than till usually is, or well, than the parent material for the moraines usually are. So I'm kind of curious to know like how to characterize the parent material for that. And then the big question, of course, is when was each landform deposited or eroded into its current position and shape? So, does anyone have any questions for me?
Adams State College. Great stories begin here.